Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. In this video, we're going to look at two examples of looping programs in Python. You should try to write the programs, then we'll review my solutions together, and then I'll show you some real-world context for the sort of program I've asked you to write. Let's jump in. Program 1, totaling numbers in a pattern. Write a loop that adds together every third number from 1 through 100 and then prints the result. So the loop will add 1, 4, 7, etc. through 97. The result should be 1,617. Pause the video and write the program in idle, or use the code check linked in the description. How'd you do? Here is my solution to the problem called pattern_total_solved.py. You could write this with either a for loop or a while loop. You can write any loop with a while loop. I've chosen a for loop here because we know, as we write the program, exactly how many times the loop will execute. When we know that, the best choice is a for loop because a for loop is a more readable loop. All of the loop control information is in the first line of the loop, so the person reading the code knows at the top of the loop how many times it's going to execute. Because we're totaling, we'll need an accumulator variable, a variable that accumulates or gathers value into itself each time through the loop. I've called that variable total, and before the loop, I've initialized it to 0. My loop control variable is called I. This is a common name for a loop control variable that is going to take on a predictable series of values, and when we get to lists, you'll see that the I is short for index. My loop header is for I in range 1, 100, 3. The range function generates a series of values based on the arguments we pass into it. The first argument is the start, the second is the stop, and the third is the step. If we have only one argument, it's the stop, and the default start and step are used, 0 for start and 1 for step. If we have only two arguments, it's the start and stop. I want to include all three so that my loop control variable I will start at 1, not 0, and so it will jump by 3 each time through the loop. If you want to see a range, you can type the range in the console and wrap it in a list. So list range 1, 100, 3. That will put all of the values that will be in the range in a list and display them to you. When we combine a range with a loop, the range defines all of the values that the loop control variable will take on as the loop executes. When I run this program, it prints the total of every third number from 1 to 100 is 1,617. We're actually finishing at 97, not 100, so we could put 98 as our stop value, but if we put 97, it would be skipped. The stop value in the range is the value the range will stop before. If you want a number included, you should make the stop value one more than that. Okay, so how many times have you been assigned a loop like this and wondered why? It seems pretty silly and pointless. I'm going to show you a real-world context that will illustrate why you need to be good at writing loops that include a stepper variable, in this example I, following a pattern. This program is called pattern_total_context.py, and what I have over here is a text file called aiinvestment.txt. This is from our World in Data. I'll include a link in the description. It's how much money was invested in AI by type of business for the years 2017 through 2021. You can see that this file is organized with one piece of data per line, but it's grouped into records. So the first line of a record is the type of business, the second is the year, and the third is the amount invested in AI by that type of business for that year. Suppose I want to total the 2019 investments across all business types. How do I do that? I need to figure out the pattern, and then I can write a loop with an accumulator very similar to the loop we just wrote. In my solution, I've read the entire file into a data structure called a list. The variable name of the list is data. A list is an ordered collection of data, where each element is accessed by its index, basically its number. List numbers start at 0. So each line of the file will be in the list in order, with agricultural tech in the first location, numbered 0, 2017 in the second location, numbered 1, etc. The value we want to start with is at index 8, and the next one is at index 23, 15 from index 8. Each 2019 value is 15 locations from the last. The trick here is that the pattern is in the indices, in the locations of the values I want to total. So I can write, for I in range 8, len data means the end of the list, where I want to stop, and then 15, the increment. And then total plus equals int data open square bracket I close square bracket. We read that as data sub I. That's how we get to the actual value at that location. I have to convert it to an integer because when we read from the file, everything gets read in as a string, even the numbers. It is very common in data analytics or really any data manipulation to pull out specific values that occur in a pattern in the data. Finding patterns and writing loops that can follow those patterns is a valuable skill. Program 2, Consolidating Files. Write a program that combines several files into one. The program asks the user for the file names in a loop until the user types done. For each file name, the program should check if the file exists, and if it does, it should read every value in the file and append it to a file called consolidated.txt. For simplicity, each file should be in the same directory as the program. If the file doesn't exist, the program should tell the user it couldn't find the file. If it does exist, the program should print a message letting the user know the file's contents were added to consolidated.txt. To test this program, you should create several text files to be consolidated into one and put them in the same directory as your program. Pause the video and write the program in idle, or use the code check linked in the description. How did you do? Here is my solution to the problem called consolidatesolved.py. We need two loops for this program, one inside the other. The outer loop gets file names from the user until they enter done. The inner loop reads the lines from the file and writes them to the consolidated.txt file. The outer loop is a sentinel-controlled loop, and the word done is the sentinel. In a sentinel-controlled loop, the sentinel is the last value in the input stream. In this example, the input stream consists of file names until the user enters the sentinel, done. A good way to structure a sentinel loop is with a priming read. So we first get a file name, or the sentinel, from the user. That's on line 31 with our input statement. You then have the loop header. We must use a while loop for a sentinel loop because we don't know how many input values there will be until the user is finished entering values. So while filename.lower is not equal to done. I'm converting the value the user gave us to lowercase and comparing it to lowercase done, so we don't have to worry what case the user typed the word in. This will match every case configuration of the letters D, O, N, E. Now, if we're in the loop body, it means the user didn't enter done, and I can process the file name that the user gave us. The updater is at the very end of the loop on line 51, where I prompt for the next file name. When we structure a sentinel loop this way, initializer before the loop header, and then updater at the end of the loop body, we never have to worry that we're accidentally processing the sentinel value. We don't want to try to open a file called done, and we won't with this loop structure. Inside the loop, now we have a file name, so I'll first check if a file with that name exists. If it doesn't, we print a message to the user, letting them know we couldn't find the file. If it does, we open it, and now we're going to loop through this file, reading each line and writing each line to the consolidation.txt file. I created that file on line 28 before the loop. Outfile equals open consolidated.txt w, opening the file in write mode. So that file is ready to be written to. My file reading loop is structured very similarly to my sentinel loop. I read a value from the file, check if it's end of file, and if it isn't, I write it to the consolidation file and then read the next line of the file. So the initializer is before the loop header, line equals infile.readline, and then the loop header checks if that line that I just read is the end of file. If it isn't, we go into the loop, write that line to the consolidation file, and then we have the updater. We read the next line from the input file. So we'll never try to process the end of file marker. A file reading loop in Python is another example of a sentinel loop, where the indicator that we're done, the sentinel, is the end of file marker, and it's in our input stream. Either the variable line is going to hold the next line in the file, or it's going to hold the end of file marker, and we're done. When we're done reading from the file, we close it. I've created 3 files of data from a file I downloaded from ourworldindata.org. And again, I'll put a link in the description. These files are the LGBT equality index values for different countries. So I've separated them into country names starting with A, country names starting with B, etc. Very often you will have data stored in separate files, and you'll want to consolidate those files to facilitate analysis. So I'll run my program, and I'll type LGBT underscore equality underscore index underscore A dot text at the prompt. And it reports that it's been consolidated, so I'll type LGBT equality index B dot text. Consolidated. LGBT equality index C dot text. Consolidated. LGBT equality index D dot text. Now, that one doesn't actually exist. The program tells me it can't find LGBT equality index D dot text. That's the else inside my outer loop. I didn't enter done, so we checked if the file existed, and it didn't. Now I'll type done. And here's the consolidated.txt file containing countries with names A through C. Now, this is a real-world sort of program, but in the real world, it's more likely you'd have the program interact with the file system rather than the user. So you might have the user give the program a directory name, a folder name, and the program would use the OS library to interact with the operating system, getting the list of files in the directory and consolidating them. A real-world program is also going to include a lot more defensive code. When we're teaching programming, we often skip some of that defensive code because it complicates programs and obscures basic programming structures that beginners are just learning. Here's that version of the program called consolidate_os.py. In this version, I'm prompting the user for a directory or folder, and I'm using os.listdir to get a list of the files that are in the directory. Now, this will only work if the user hasn't filled the directory up with stuff they don't want consolidated. It should just be files that are to be consolidated. The program then opens the output file in the same directory, and then loops through the file names in the list it got from the operating system, opening them and writing their contents to the output file. In this program, there are lots of try, except, else blocks. This is that defensive code I was talking about. If the user gives us a bad directory, or if there's something wrong with one of the files in the directory, we'd like the program to fail gracefully. What a try, except, else block does is allows us to try executing a line of code, and if it raises an exception, an error, the code in the except block executes. But if it doesn't, if it was successful, we can move on to the else. So as an example, on line 26, we try to get a list of the files in the directory provided by the user. If that isn't successful, for example, if the user types the name of the directory wrong, then the except code on lines 28 and 29 executes, and it prints a message. The else is then skipped. But if it's successful, we go into the else and try to create the output file. If that's successful, we go into an else and try to consolidate each file from the directory. When we're teaching introductory programming, we often make assumptions to simplify the program. So we assume the directory name is typed correctly and the directory exists, and we assume nobody's going to delete a file while we're reading from it. This is similar to the frictionless surface we assume in introductory physics classes. We're assuming certain conditions so we can focus on the aspect of programming we're learning right now. In this case, loops, and specifically, file reading loops. You might agree that if you were dropped into a program structure like this one in an introductory course, you'd feel a little overwhelmed. But eventually, this might still be a little overwhelming to look at first, but when you read it slowly and carefully, it will make sense. So I hope you found these examples interesting and helpful, and that you were able to program them yourself. If you found them challenging, try again, and check back with the video if you get stuck. The code solutions for these programs are available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.